All right, so let's start off with share screen and we'll get the notes going. Oh, I've got to open up the ladybug first. So we are doing day 2 of Trig identity, focusing strictly on the differences. So this is going to go with the assignments portion of it. And can't see it yet. So now that it's open on my end, I could go ahead and share it. There we go. And see if you get it so it's not so blurry. All right. So we talked yesterday. There's 2 different types of scenarios you're going to come across with the formulas. So when we see the ones with the degrees, we know that we're going to be going to our unit circle for that. So we would have our unit circle that we could look at, different than the ones that give you these values here. These ones are saying that we're going to need to create triangles to be able to figure out the missing values. The formulas we go back to are the same. I went ahead and printed the formula sheet that I had sent out on that's in Google Classroom. So you can see the formula sheet kind of has everything. It has law of sines, law of cosines, law of tangents, which we didn't really focus on. So it has a little bit of everything. It's just a great sheet that kind of goes through our inverse properties, domain and range that we had worked with. So it just kind of has everything you need all in one spot, as well as here's all the different formulas that we're going to be coming across, working with. There's our even and odds that we've seen. Our sum and differences are right here. So these are the formulas that we're focusing on. So I just want to point out how it works here. So notice that if it's sine and it's sum, it could be x plus y, whatever notation, a and b. These are just symbols to represent. So if it's a plus, then it's going to match up with the plus on top. So whatever's on top matches with the sign on top when you look across. So when I look at my cosine, it's a plus on top, then it's going to be a minus to go with it. The sign on the bottom, the minus goes with the sign on the bottom, the plus here, just to help you guys make sure you know how to read the formulas. But again, they're all in one little spot. So these are our sum and differences. We're going to be doing half angles. We're going to be doing product sum, sum to product. So we're going to be using all of these. Here's our co-functions that we saw yesterday. So all of these are here in one spot, super helpful. Okay, so let's go ahead and let's get to work. I'll write down the formulas at the top that I'm going to use for it. Again, all the formulas are going to be coming from my differences. So you could look at it here, or when I posted it yesterday, it was at the top of my paper, but I will write them out. So the first one says, find the exact value. So of sine of some A value, cosine of some B value, minus cosine of that A. This A is going to represent the 40 degrees, right? Some unknown, sine of B. So this B is representing 20 degrees. So I could see here that my A is 140 degrees. My B is going to be 20 degrees, is equal to what? So I'm working backwards. I'm taking these because these aren't on my unit circle. They're not on my unit circle. And if I want to find the exact value, I have to use unit circle. Remember, these are not saying plug it into the calculator. Calculator is going to give me a rounded decimal. This is going to be exact value, which means I'm using my unit circle. So I need values that are on my unit circle. And here's what I know. If I look here and I have sine of A, cosine of B minus cosine of A, sine of B, so I have a sine and cosine combination, sine and cosine combination. My other option is cosine, cosine. So we know it's going to be a sine because that's matches with what we're given. It is a minus in between. So over here, it's going to be a minus in between. So minus is at the bottom. I use a sign at the bottom. So this right here is equal to sine of A minus B. So it's just equal to sine of 140 degrees minus 20 degrees is equal to sine of 120 degrees. And you know what's so nice about the sine of 120 degrees? It's on my unit circle. So all I need to do is I go to 120 degrees. Sine is the y value, so it's just the square root of 3 over 2. So this whole thing right here is just equal to the square root of 3 all over 2. Done. That's it. So if these values aren't on my unit circle, then I need to go ahead and see, well, what happens if I combine them, if I write it as a single term? And I was able to solve it. That's it. No calculator, so don't go to your calculator. All right, so this one was the ones that were a little bit more work because I'm gonna have to create triangles. I already know I'm gonna have to because they wouldn't make it that easy for me. But what is it gonna look like? All right, so I need to find cosine of alpha minus beta. These are just Greek letters. It's like an A and a B. If you don't like this and you want to change this to an A and these to B's, go for it. Doesn't matter. It's just a placeholder. So I know that cosine of alpha minus beta is equal to, going to my formula sheet, cosine, it is a cosine, it's a minus, so it's going to be a plus in between. So it's cosine, cosine plus sine, sine. So it's going to be cosine theta, cosine beta plus sine alpha, sine beta. That's a sign there. Doesn't look like it. It's messy. You guys get it. So then I plug in all the pieces. So I look here and I go, okay, well, I know that sine alpha is -4 fifths pi, or sorry, -4 fifths. So I go to my sine alpha here. This is going to be a -4 fifths. I also know that cosine beta is -5 eighths. I know it's a plus in between. What I don't know are these two pieces. So there's information I don't know. And again, that's where I have to go to my triangle. So I know these two pieces are given to me. I plugged in those two known pieces, but I still need to figure out more information. So I know that my alpha is in quadrant 3. So I know that my alpha is in Q3. What that means is that all students take calculus. That means that tangent is positive. So if tangent's positive, then I know my sine and my cosine value are going to be negative. I also know that I was also given that sine of alpha is -4 fifths, which makes sense. It has to be negative because tangent would be positive. What I need is cosine of alpha. So we want cosine of alpha, and I already know because we're in quadrant 3, tangent's the only one positive, so cosine has to be negative. But I don't know what those values are. And this is where I go ahead and I make my triangle. So here's what I know. I have a right triangle. I know this is my angle alpha. I know that this is my opposite over my hypotenuse, and I want my adjacent over my hypotenuse, right? Because it's cosine. So my opposite side was 4. My hypotenuse is 5. Then I'm going to have a 3, 4, 5 triangle. It's probably the most common one that you guys are probably pretty familiar with that. If I didn't know that, I could use Pythagorean theorem to solve for this missing side. So this tells me then that it's going to be a -3 fifths. Cosine of alpha is a -3 fifths. But I still have to do this for my other ones. So these ones require a little bit of work. It's not difficult, it's repetitive. It's the same idea each time. So I know that this beta value exists in quadrant 2 this time. So they're different quadrants. And this tells me all students take calculus. So if I'm in quadrant 2, my sign is positive. Sign is positive because I'm in quadrant 2. I was given cosine of beta is -5 eighths, which makes sense. It has to be negative because it's only going to be sine that's positive here. I want, for my beta, I want sine of beta. So I want sine of beta, and I already know, because again, I'm in quadrant 2, that it has to be positive. So I want to figure out, okay, well, what is that going to be? I have to draw my triangle. Here's my beta, here's my right triangle. This is my adjacent and my hypotenuse. My adjacent side and my hypotenuse, right? So my adjacent side is 5, my hypotenuse is 8. I want to figure out what this missing side is. What is my opposite side going to be? So I just used an O for opposite. You can use an X, whatever you want. So I know that 5 squared plus my opposite side squared is equal to 8 squared. 25 plus my opposite side squared is equal to 64. Subtract 25 from both sides, and I get my opposite side squared is equal to 39. Take the square root. My opposite side is the square root of 39. I can't simplify that at all. It's 3 times 13. Those are both prime numbers. So this is just going to be the square root of 39. This tells me then that my sine is a positive. Again, we're in quadrant 2. Sine is positive in quadrant 2. It's a square root of 39 all over my opposite side, which is 5. So I now know this is the square root of 39 all over 5. So all that work, and we haven't even actually solved it. So now I just need to clean this up. I just need to simplify, clean this up. So it's going to be -3 times a -5 is a positive 15. 5 times 8 is 40. A negative times a positive is going to be a negative. So it's -4 square root of 39, again, all over 40. And we could write this since they have a common denominator just as one term. So we would say 15 minus 4 square root of 39 all over 40. So I look for the matching answer, and it's going to be right here. Something I want to point out, if you remember, if my little triangle of values, the coefficient, the leading term, and the denominator have something in common, then I would need to make sure that I simplify. So just kind of keep that in mind. Again, if this would have been an even number, then I could go ahead and I can simplify. Let me open up my chat. For when we just simplified. Where did we get 54 from? Boom. Oh, sorry, I wrote this wrong. That's why. This is an 8. I treated it correctly. Sorry, opposite over hypotenuse, it's an 8. It should be an 8. That's my fault. Should be an 8. Should be an 8. Should be an 8 here. So it should be a denominator of 40. It's always going to work out where they have a common denominator because they're always using that same hypotenuse for both of these. So these denominators, when you work through these, will always end up being the same. So yes, you are absolutely correct. Thank you for catching that mistake. Sometimes I just think too quickly in my head, and I'm sorry. So yes, excellent. My opposite side, so remember this is opposite over my hypotenuse. My hypotenuse was 8. I wrote it as 5. I did treat it as 8 up here. So this is an 8 and it should be 40. So the answer is still correct. Thank you so much. Any other questions? Because that's a big problem. This is pretty much as complicated as it gets. It has the most amount of work, which makes it more complicated for you guys. But what we did here is exactly what we did here. Alrighty. So next one is going through the steps. So don't get so caught up in the vocabulary of it all. Just kind of see, well, what exactly are they doing? And so all they're actually doing here is they're going to go ahead and use the difference formula. This is a sign, and it's the difference of two values, right? So this is going to help set us up for some of the problems that we're going to come across on the back side. So when I look here, it's this sign and it's a difference. So it's a minus, which means it's sine of that first term, cosine of the second, and then it's a minus again, and then it's cosine sine. So let's look at what it's saying. So this is going to be sine of the first term. So this would be sine of my pi over 2 cosine of that x. And then it's going to switch. So then it becomes cosine of your pi over 2 sine of the x. And there's some things that we know. We don't know what x is. That's some unknown. So there's nothing we can do about that. We don't know what x is. But what we do know is this value right here. We know sine of pi over 2 is equal to, that's on my unit circle. Pi over 2 is on my unit circle. Sine of it is just the value of 1. So sine of pi over 2 is just the value of 1. So this piece right here is just the value of 1. I also know cosine of pi over 2. And cosine of pi over 2 on my unit circle, pi over 2, cosine is 0. Cosine is 0. So this value is just 0. And 0 times anything is just 0. This just cancels out, right? That's just minus the value of 0. That's nothing. And 1 times cosine of x is just cosine of x. So they're having you basically prove the cofunction identity. And here's what they said. Sine of pi over 2 minus theta, some unknown, some x, is just cosine of that value. And that's exactly what we just showed. We worked it out to show that, and that's all they want you to do. But this idea of having something we know mixed with an unknown means that we can solve for a value of x if need be. So I was able to simplify some of it within it. Even though I didn't know that value of x, I was still able to simplify. And we're going to apply that knowledge on our last problem. So let me go ahead and do one more before we do that. Go ahead and flip. Tangents scare us sometimes. We don't like tangents. A lot of the times, the problems that we're seeing don't have the radians, they're in degrees, which you guys tend to like better. But even if we're given radians, remember, they're on the unit circle. If it's on the unit circle, then we just go ahead and we could go ahead and just, what are the values? We could plug them in. Just like we did pi over 2, we were able to figure out sine of pi over 2 is just 1. We can look. When I look here, 3 pi over 7, 3 pi over 7, that's not a value on the unit circle. So very similar to our first problem where we were given 140 degrees and 20. They weren't on our unit circle, so we had to work backwards. So this isn't on my unit circle. This isn't on my unit circle. So our goal a lot of times is to work backwards and put it together. And so we could solve it. Doesn't mean it's always the case. So this one, we had to work backwards. And in other words, put it in the simpler form. This one, they actually tell us to write it as a single trig. So they want us to write it strictly as a tangent of something. So it's like we're working backwards. So it is tangent, and I need to match it up. Is it going to be tangent, and am I going to be adding the two values, or am I going to be subtracting? So here's what I do. I look here, and I see it's a minus and a plus. So if it's a minus on top, I'm looking at the bottom one here, and the bottom one, which means it's going to match with the bottom one. So this is going to be equivalent to a minus. And I'll go ahead and write out the whole formula. What this tells me is that I'll just use A's and B's because I feel like you guys do better with that. Tangent of A minus B is equal to tangent of A minus tangent of B all over 1 plus tangent of A tangent of B. So this is the equation that I'm using. And again, my signs match up. It's a minus and a plus, a minus and a plus. That means that this is my A, this is my B. Again, A and my B. So I know that my A is 3 pi over 7. B is 2 pi all over 5. So I plug in my pieces. I plug in what I know. I plug in everything I know. So it's going to be equal to, so this is what I'm given, and I'm going to write it into this format. So it's going to be tangent of 3 pi over 7 minus 2 pi over 5. I could clean this up. I could simplify this, but I have to get a common denominator. So this is just going back to our basic math skills of adding and subtracting fractions. I need to get a common denominator. So my least common multiple, the smallest thing that both of them go into, is going to be a value of 35. Yes, I'm going to go ahead and I'm going to multiply this term by 5 over 5. I'm going to multiply this term by 7 over 7, and I get tangent, and it's going to be 15 pi minus 14 pi all over. So 7 times 5 is going to be 35. 15 pi minus 14 pi is just going to leave me with a pi all over 35. You could write 1 pi out in front. It's not necessary. And I could see that my answer matches right there. And we're done. All right. Now we've got a really fun one. Okay, so this next one, I say it's really fun and I say it sarcastically because it does take a lot of work. Here's the deal. If you just take it piece by piece, it's not overwhelming and it's really not that bad of a problem. These type of problems scare you guys. Don't let it scare you. Again, take it piece by piece. There's a lot going on, so I will take my time kind of going through it. But I hope that you guys can do these on your own. This is basically putting everything that we've been working on together in a little bit more of a complicated problem. Okay, so I say take it piece by piece. What they want us to do is to solve for x. Well, where do I even begin? Well, I know I'm working with sum and difference identities, so I want to use that idea. And I look here and I have a piece right here, and I have a piece right here. I'm going to focus on these two pieces separately for the moment. That's because this piece right here, this tangent alone, this can be used in one of my difference formulas, my tangent difference formulas. It's tangent and it's something minus something else, minus pi. So it's some unknown minus pi. And that has its own formula. That's what we were using up here. We were using the formula up here. This is what I'm using for that tangent piece. This is exactly what I'm going to use. So this would be my A value. This would be my B value. So my tangent I already have right here, and I'm going to plug it in as is. So here's what it's going to look like. I'm going to take that tangent and I'm going to rewrite it using the difference identity. So it's going to be tangent of x minus tangent of pi, because that's what I have as my A and my B, all over 1 plus tangent of x, tangent of pi. All right, so that's this first piece. Then it's minus, and I have a cosine. This right here is also a cosine difference. This is my difference identity for cosine. And so I'll go ahead and write that formula up here just because I don't have it on the paper for you guys, and you guys can look at it. So remember, cosine of some A minus B is going to equal cosine of A, cosine of B, plus sine of A, sine of B. So this is my cosine equation that I'm going to use right here. So I'm going to plug in these values. Now again, this would be my A and my B value. So it's going to be minus, and I'm going to plug it in. So it's going to be cosine of x, cosine of 3 pi over 2. This is going to be minus this whole thing, right? Plus sine of x, sine of 3 pi all over 2. So this right now looks really overwhelming, but I have a trick to simplify this because there's things that I know, whether you realize it or not. I know tangent of pi. I know what my tangent of pi value is. Tangent of pi is on my unit circle. And remember, tangent's my y over my x value. So tangent of pi, I look at my unit circle, I go to my pi. Tangent of pi is 0 over -1. 0 divided by anything is going to be 0. Now remember, if 0 is in the denominator, it's undefined, but 0 in the numerator just makes it 0. So wherever I see a tangent of pi, I can plug in the value of 0. This is just the value of 0. Very similarly, I also know cosine of 3 pi over 2. I also know cosine of 3 pi over 2 because it's on my unit circle. And so I go to 3 pi over 2, 3 pi over 2, and I look at the cosine value, and it's also just the value of 0. It's also just the value of 0. So I look here, and I know that this is just a value of 0. It's already starting to look much better, isn't it? And my last one that I know is the sine of 3 pi all over 2. So sine of 3 pi over 2, sine of 3 pi over 2 is a value of -1. So it's equal to -1. So this piece right here is a -1. So I'm going to clean up everything that I have. I'm going to make this look a little bit more organized. So I know since this is 0, tangent of x times 0, this is just going to be, the whole thing is just going to be a 0, right? So this is going to be tangent of x all over 1, which is just tangent of x minus, this whole thing is just going to 0 out, so that's a 0. This is going to be sine of x times a -1, so minus sine of x. Of course, I didn't need to put that there, but also remember that this needs to be multiplied through. So I get tangent of x plus sine of x. Okay, now here's the tricky part, because I didn't write that this whole thing is equal to 0. Remember that this is all equal to 0. This is all equal to 0. And I'm asked to solve for x. My whole goal here is to solve for x. I simplified things and I have just this equation, but how do I solve for x? So we want to know what x is. Okay, so in order to do that, we need to, this is again built on prior knowledge. We were able to solve some at the end of second semester. We need to basically get the equations into something where we can, it's either factored or it's all in one term. It's either all in sine or cosine. And so this is one of the trickier ones, and I'm going to show you how I would go about this. Now remember, tangent is just going to be sine of x all over cosine of x, right? So that's equivalent. Tangent is just sine of x all over cosine of x. And I have my sine of x is equal to 0. Now things are looking uglier. You guys are like, well, how is this helping me? How is this helping me? Well, here's what my next step would be. And I'm showing you this one. I picked this one out in particular because this is sometimes things we don't think about. Well, now I want to get a common denominator. So I'm going to multiply this by cosine of x all over cosine of x. And I get sine of x plus sine of x cosine of x all over cosine of x is equal to 0. I don't like this fraction, so I want to get rid of my denominator. In order to get rid of the denominator, multiply both signs by cosine of x. This is still just going to be a value of 0, right? So this is telling me sine of x plus sine of x cosine of x is equal to 0. You guys are like, well, this is not looking any better. I know, just hang in there with me. If I look at these two terms, they have something in common. They both have a sine of x. So I can factor out a sine of x, and when I do so, I'm left with 1 plus cosine of x is equal to 0. And this is what I wanted. According to my zero product property, just like if I had something like x times x plus 1 is equal to 0, we would set each of these pieces. I would set x equal to 0, and I would set x plus 1 is equal to 0 to solve it. Same idea happens here. So now, according to my zero product property, same property is here. They just have that sine or cosine with it. I have that my sine of x is equal to 0, and I have 1 plus cosine of x is equal to 0. And I can solve. This is telling me, this is asking me, hey, when is sine of x going to be 0? In other words, when I look at my unit circle, when is the y value 0? So when I'm on my unit circle, sine's the y value. So when is the y value 0? It is 0 here at 0, and it is 0 at pi. How come I didn't use the degrees? Because in the problem, it's saying between 0 and 2 pi, which means I'm using the radians. So again, sine is 0 at 0, and sine, or the y value, is 0 at pi. So the answer for this piece is at 0 and pi. This is saying I need to subtract 1 from both sides because I'm solving for cosine. I want to know, when is cosine of x equal to -1? When is cosine -1? So on my unit circle, when is cosine -1? Remember, cosine is the x value, and cosine is -1 at pi. So this is telling me that x is equal to pi. So what is the answer? These two happen to be the same. That's okay. So it's at pi and at 0, and this is the answer they were looking for. So again, that's a lot to take in. This piece right in here is probably the trickiest. How do I manipulate it so that I can actually solve it? So some of them you might need to play around with. The ones with tangent are the hardest. Look for things that you can factor out, and that so that you could get something like this. If everything simplifies and you just end up with just a sine or just a cosine, then that makes it easier for you guys. So you get some different variations. So kind of use this as a guide as you go through today. So this is your assignment. This is on your assignment. And of course, I have more examples on Monday for the quiz. If you guys have any questions over the weekend, please reach out to me. I'll be around. Otherwise, you guys have a fabulous day. Any questions? Yes, it is definitely a lot of replacing terms with other terms. That is this rest of this chapter, that's what it's about. So follow the formulas and look at it piece by piece, because if you look at the whole thing, you're gonna be like, I don't even know what to do. Yeah, so you definitely have that. If you guys need anything, seriously, just let me know. If you get stuck and you're like, I just don't know what to do, I've been playing around, just send me a message and I'll take a picture and send you back some work, and hopefully that work will help you guys work through it and understand. And if you guys have more questions, just let me know. All right, you guys have a wonderful day. Stay dry, enjoy the rain. Bye, Rob.
Bye. Have a good day.
See you all.